How is everybody today? Excellent. So I'd like to zip through the material we have today. So we're going to talk about version control software. This is, possibly one of the more important lectures that you'll listen to sort of give you the idea and the flavor how these modern version control systems operate. Hello? I'm going to have to call you back. I have to take those. One of them might be my wife. One of those might be the call. So, anyway, where was I? Version control. Yes. So, version control software is basically like, if you don't know how to use it, then you have no hope in hell of ever, landing or keeping a position in industry these days. It's absolutely standard, so it's good to know, at least in general terms, how it works, what it is, how to use it. So, did I do this slide already? Yeah, I did this slide already. So, this is a rough estimate of the popularity of various forms of version control through the years. You can see it's ending in 2015, which is quite some time ago now, but you can see what the general trend was at that point. I can tell you that Git has only become more popular since 2015. So the trends that you notice seem to have continued, at least in my estimation, and in the absence of any official data. But way back in 2008, SVN was dominant, but over time, Git has come to overwhelmingly dominate the market in version control systems. This is because it is a bit easier to use, less finicky in its interface. It does more things automatically for you and is just overall a better product in general. I think that's fair to say, especially given, with these software products, once they sort of achieve a critical mass of popularity, people tend to contribute to them in an open source way that continues to expand the goodness of the product. So you kind of have the snowball effect of wonderfulness. So, Git was created in 2015 by our good buddy Linus Torvalds, who was he? What else did he invent? Remember from last lecture? Yes? Linux. He named it after himself. Git is British slang for an unpleasant person. Apparently, people found him to be one while working with him on projects. So, I see I cut off the slide, but anyway. So he wrote Git as his own version of Subversion, his own version of, repo control, named it, again, after himself. So Linux is named after this guy. Git is named after this guy. If you're wondering about the context of this particular photograph, this was taken at a conference where he was complaining that NVIDIA just completely will not play ball with Linux, and they're the only company, hardware manufacturer, that won't play ball with Linux and support Linux drivers and that sort of thing. So he's like, there's no reason to not support, talk to us. We want to support your hardware, but you're just being difficult. So, there you go. So today, the most popular way for people, sort of regular folk who don't own their own servers and that sort of thing, to use Git repositories for, interpersonal repository communication is using a internet service called GitHub. This is, of course, a fairly broad service. At one point in the recent past, it was acquired by Microsoft. Prior to its acquisition by Microsoft, hidden or private repositories were something you had to pay for. Now you've got pretty much free reign of the platform, except for very large projects. They've kind of changed the model. If you want like a very large project, you have to pay for the license. But as long as you're like an individual doing individual things, it's pretty much completely free to use, which is nice. But also, it's Microsoft that made it that way, so you should be suspicious. Because Microsoft is the worst company in existence. There's absolutely no reason why any of you should not have a GitHub account and have GitHub projects. Basically, one of the ways that GitHub is used is to hire people, because if you have, basically, in order to be hired as a software developer these days, it's very useful to have software projects that you have worked on, hopefully brought to fruition, and possibly even commercial release. GitHub is an excellent platform for, pinning up your posters, as it were. So it's kind of also like straying into LinkedIn territory as well. But yeah, GitHub is a very good thing to use. In this course, we're going to be using an alternative to GitHub called GitLab. The server is owned and operated by the department, so you don't have to worry about Microsoft or any third parties being able to see all of the stuff. It's just the university that you've sold your soul to. So yeah, I'm sure I don't have to press you guys too far on GitLab, because I'm sure that all of you have managed to get your login credentials sorted out by now, right? Good. If not, talk to Sebastian. So with respect to the manner in which data is stored inside of these repositories, traditional repository systems operated on a more traditional client-server model. So you'd have one server which held the repo on its hard disk, and then each of the clients would interface with one centralized server, right? This, incidentally, is what it's like when you use one of these Git repos that's synchronized through our website, right? GitHub itself is acting as server, and you are the client interfacing with it, right? However, Git is a little bit more general than that. In fact, Git operates on a distributed model. In theory, this means that if one client in the network goes down, they only lose their local changes. Whereas in the traditional model, if the server goes down, everybody's effed, right? So, in practical terms, a server is still necessary to coordinate distributed clients, but it's, okay, I'm going to talk very briefly about the Vigima games. You know Dark Souls? Like the first one? So you may not have known this, but the multiplayer functionality in the, I'm not sure if they've changed it for later ones, but certainly Dark Souls 1, that was actually run on a distributed model, which had two great benefits. Number one, it saved from software the cost of server maintenance and operation, because basically whenever you're online with Dark Souls, your computer itself is part of the network that's all doing all of the network things. They don't have a centralized server, right? So that's number one. Number two, it meant that when Hasbro or whoever it is that owns From decided to shut down the multiplayer for the original Dark Souls on people's computers, shortly in advance of the release of Dark Souls 3, I believe, to try to kick people onto the new one and get them to buy it. All it took was a very simple patch that somebody very quickly wrote up that re-enabled the distributed network, and that network persists to this day in the absence of its corporate overlords. So distributed networking is a very good and powerful tool. Any questions about that? Any questions about Dark Souls? Yes?
So the client would be like the user computer?
Yes. Yeah, the client, in all of these, the client is the user's computer, right? So it would be possible, right, for you and your friends to just get together, form a distributed Git repo network without needing to actually even bother with GitHub. But because GitHub makes things very convenient and has actually a large number of interesting and useful bells and whistles, generally speaking, it's come to dominate the market through convenience in kind of the same way that iTunes killed the music piracy, thing. Make sense? Yeah. Any other questions? Moving right along. So let's get started. So even if you have GitLab or GitHub hosting a repository and all you need to do is to download that repository, there's kind of a distinction between a distributed repository and a single instance of a repository that you keep on your own machine. It is possible to operate a Git repository in the absence of any networking whatsoever. You may wish to do this, for archival reasons or something like that. It's useful to know this process because it's very similar to the process that GitHub uses to initialize you a repository. If you want to use Git on your computer, you'll need to download it. If you don't already have access to it, if you're on something like a Unix-based system, then this should be relatively easy. If it's Windows, then follow the instructions. But in general, GUIs are fine to use, but command line is usually faster and can be integrated into scripts. So, you'll be able to find Git clients and things like that, typically okay to use them. Professional software developers, however, are expected to know how to use a command line, so, it's good to know. To create a new Git repository, the command is git init. This creates a new folder which has been set up with the hidden folders and information necessary to maintain a Git repository. In Unix, files and folders with the single period character prefix are hidden files. You can use them by adding the A flag to an invocation of ls. So let's see what this looks like. This is 2M3. So, git init. So let's make the folder, make directory my repo, cd into that repo, git init. Initialized empty git repo in that very long place. So you'll see that, just calling up and asking for the contents of the folder, you don't see anything. But if you ask for the hidden folders, you'll see that .git is there. All of the information that Git needs and keeps track of will be stored in that folder. Make sense? the whole idea of Git is to be minimally invasive on the directory structure and the files that it's keeping track of. Ideally, you'll forget that it's even tracked, except you won't forget that it's tracked because you'll, commit your work frequently, Don't forget to commit things, but, you should, while you're working on things, you shouldn't even think of it as a Git folder. So, this is your rough, question?
If you were to commit, if you were to create multiple Git repos in the same folder, would the naming be different? If you use the ls name?
I don't think that it would let you. I think that it would say something like, this is already a Git repo, but let's see. I might break everything by doing this. There you go. It reinitializes the existing Git repository. So to initialize it, it looks like it's I don't know if it keeps the history or whatever. Maybe that's used to reset the settings to factory settings or something like that. I'm not sure, but certainly it's aware that it didn't allow you to put two repositories into the same folder. Yeah. A lot of Git's functionality uses the current working directory to indicate what repo you're in anyway. So yeah, you should almost think of it like I have put a little star on this folder. That's now a Git repo. Make sense? Any other questions? Yes, sir.
So why does Git want to hide itself?
Why does Git want to hide itself? It's not really needed. You don't really need to know. It's like, why are the standard libraries out of the way? Because you don't really, as long as the interface works, you don't really need to think about it. It's like, it's the principle of abstraction, right? The less you need to see about it, the more you can just use the interface, the faster you can get your work done.
So does it matter really where you can get
Um,
folder?
Whichever folder you put it in, that and all subdirectories will be a repository, right? So if you want, so, let's say you have a folder that contains, three other folders, right? You can make this one a Git repository, this one a Git repository, and that one leave it blank. But essentially, it's the contents of all of these folders which become the repository. And the same here. So you don't necessarily need to have, what am I trying to say? A folder can contain many Git repositories, but a folder cannot be multiple Git repositories. Does that make sense? That being said, there is the ability to make a submodule Git repository where one repository basically interfaces and collects data from another. That's a thing you can do, but we're kind of at the basic level here.
So basically when you initialize Git in the folder, you're just making that a Git folder.
Yes. I think the best way to think of it is as a modifier on the folder. Cool. Any other questions? These are good questions so far. Yes, sir.
So for our assignments, we would create a repository for this class called MT2MP3.
Yep.
And then inside it, we would have other folders for each assignment, right?
Yes. So, yeah, for this class, yeah, you will have, your 2MP3 repository, that will contain a folder for A1. A1 will have folders for Q1, Q2, etc., right? You will have a folder for A2. That'll have folders for each of the questions. That's how it works, right? I rather think of because the alternative to that would be to just dump the source code for every question into one folder, right? I kind of think of this as the software equivalent of stapling your assignment before you hand it to the prof. Make sense?
Yep.
Any other questions? Yeah. Good. Yeah, we actually, there are zip files, right? When you decompress the zip file, I can't remember, I think it's here. I think you only have to be like in the root of the repo. If you decompress the zip file, you'll get the directory structure and the code stubs for all of the questions in the correct manner. If, however, it just barfs all the question folders at you, just put it in an A1 folder, and I can't remember exactly how I set it up, but one of the two of those is correct. Make sense? Question?
When you went into my repo and then you put git int, that just made my repo a repository, right?
Yes. Yeah, because it has the hidden Git folder. Yeah. This is actually not this is not specific to Git. This is how pretty much all repository software works. So, good. So within a Git folder, files and, well, folders as well, like subfolders, are either tracked or untracked. So if we imagine we have a Git repo, let's say we have, sure, this one, and we have q1.c, and then q1, the executable, right? It is possible to have this included in the Git repository's storage and to not include the other one, right? In fact, files and folders must be manually added to the repository even once you've made the folder a Git folder. Now, fortunately, there's a very easy way of doing this. You can easily add everything in your Git repository as a tracked file with a very simple command. It's git add dot. In Unix and Linux and related systems, the dot indicates the current folder. So if you ever want to reference the current folder, you put a dot. Add is recursive. So it will not only add everything in the current folder, it will add everything in every subfolder as well. So through this one command, we add everything we have, right? Very quick, very easy. This is why people like Git, because things like add are recursive by default. Now, it sometimes occurs that there are files that you specifically don't want to track. It's actually possible to set up a Git Ignore file where you can put file extensions of types of files that you don't want tracked. Sometimes when you're working with certain software systems, it'll create like log files and intermediate files during compilation that aren't necessarily useful to store, right? Normally you're only interested in storing the source code and maybe like a precompiled executable, right? You're not really as interested in the in-between stuff. So it's possible to set the Git repo up so that these types of files are automatically ignored, and you don't have to manually ignore them with the add function, right? Makes it super easy, super easy. I use Git repositories to manage my course materials for all of the courses that I teach. And I use a document generation system known as LaTeX to generate my slides. LaTeX has a bunch of different intermediate files that it generates which are essentially useless. So I will often put a Git Ignore in my course materials repos to ignore the LaTeX intermediate files because there's just no point in storing them. Storage costs space. But before I add anything to the repo, I actually have to make a file though. So touch myfile.c. Let's just add something to it. Not a real C file. There we go. So if we cat myfile.c, ba-bum. It's not a real C file. Why? It's using the wrong comment character, right? That's a Python comment character. So, if you want to add that, you can either manually specify the name of the thing you want to add, or you can just do the global add, which is easy enough. So, to view what is and isn't tracked, git status. So you'll notice there have been no commits. We'll get very shortly to what a commit is. But changes to be committed, new file, myfile.c. Very straightforward, right? Not too bad. So, as you work on your files, you periodically commit your changes to the repository. Changes which are not committed are not in the repository's history. The repository history itself is a history of commits, right? So commit is like the active, it's like the main verb of the repository, right? You can think of it like super saving your work. Because it's like a meta save that saves everything and also keeps that very lovely history. If you're working on a networked Git repository, the command, the operation which sends all of your commits out to the network to be synchronized with the network is again a separate command. In that case, it would be git push. So you push it out to the network, right? Doing this every time you commit is a very good idea, unless you're prevented from doing so for some reason by not having internet access or something, right? So, I'm going to, this is a local repository, so give me one second. This is a local repository, so there's nothing to push it to here. But git commit. Normally, it's a good idea to also include a message. This is my first commit. There we go. You can see git status. On branch master, nothing to commit, working tree clean. So this is telling me, since my last commit, nothing has changed. Right? What was your question?
So every time you make a Git repository, is it automatically set up to be able to be pushed to the network?
No. If you make a local one like this, then there's no network to push it to, right? It's just local. However, if you make your repository on GitHub or GitLab, and we're going to be talking about this in a bit when we talk about pulling from networks. What you do is you clone the Git repository from the network to your local machine. That establishes the link between the two, and then you can push and pull as much as you like. Make sense?
Yeah.
Cool. Yes?
So if you close the terminal after you like you did your first assignment or whatever, if you open it back up again, do you have to do the closing again, or is it already the latest already established on this process?
Because everything that Git needs to operate is stored in the hidden Git folder, that's being stored in permanent memory. So that is stable not only between login sessions, but also your computer powering up and down. Yeah, so making something into a Git repository is a permanent modifier. Make sense? Any other questions? Yes?
Let's say you like throughout the year you made a bunch of different repositories for every meeting that you're ready to like get rid of. How can you do that?
Just delete the .git folder. Yeah. Although that's kind of like the hacky way to do it. I'm sure there's a command for it through the Git interface itself to unrepo a folder, but because everything that Git needs and talks about is stored in the .git folder, getting rid of that gets rid of Git. Questions? Good. So this is your general workflow. Typey, typey, typey. Add, commit, push. So, I kind of have already talked, I've already given a demonstration of this. But we'll just go through it quickly. So git add file name, right? This makes Git track the file. You can add multiple file names. You can use glob patterns to target all files of a particular file extension, or like I showed you, just use dot. Git commits everything in the working directory and all subdirectories. Commit expects a log message, which can be specified using the M flag. If you fail to provide a log message, it will open up a text editor like Nano, because you probably just forgot, right? Descriptive log messages are important, like good commenting habits. Normally, when you put a log message on a Git commit, you want to say what you did on the project. Like, added feature X, fixed bug Y, addressed issue 57, all like that sort of thing, right? Or even progress towards addressing issue 57, stuff like that. So don't be this guy. Descriptive messages are important. So, here are some additional basic commands. Okay. You know what it is? It's like all these video files. Like if time shift takes a snapshot before I've like emptied my video repository, like not repository, the video folder that I use to make the videos to throw them on YouTube, if I've not like deleted everything in it and cleared the trash before they make a snapshot, then the snapshots themselves like just, I need another SSD. I just need another thing. Anyway. Git status will display the changes that have been made versus the last commit, what needs to be added, what needs to be, like what's already been added, the changes which have been staged for commit, all that kind of stuff. If you want to check things out before you commit to see if you've added everything correctly or something like that, git status is your boy. Git log displays the date, time, and author of commits on the current branch. Don't worry, we'll talk about branches. Also displays commit IDs and your lovely log messages. So that's basically, I want to see the history. Show me the history. Git log. There you go. You can also use the one-line option. One line there. There you go. That like squishes it in case you've got like 50 gazillion of them, so you can put it all in compact notation. And Git line, one-line graph. What is it? Anyway, we'll get there. So, additionally, Git Checkout is an important one. So it's not like, what's the point of having the history if you can't navigate the history, right? So when you use git log, all of your commits will have an identification number. If you check out a particular identification number or branch name, again, we're getting to branches later, it will change all of the files and folders inside of the repo to the state they were in when the commit was made, right? It's like you undo to the point of the commit that you made, the commit that you've specified, right? This is extremely useful, right? Particularly if somebody has broken things and committed a broken project. There's one on every team. So, very good, very cool. Any questions? Yes?
If you modify a file, do you need to re-add it, or how do you like update that file in the repository?
Let me show you. So, let's get it myfile.c, right? This is also not a C style comment. All right? There we go. So, am I ringing slightly? Is it annoying enough for me to take the mic off? Let me know if it gets there. So, yeah, okay. There we go. I'll just shout at you. So, view the file. You can see that the contents of the file have been updated. Git status. Modified. myfile.c. No changes added to the commit. Use git add or git commit a. So you have basically two options. You can either use the a flag on git commit to automatically perform the add procedure, or you can add it manually. But if you just commit with nothing in there, changes not staged for commit. Modify myfile.c. Right? So you have to add to stage the changes for commit as well. So you can just go like -a. There you go. The commit has been made. And if we git log, you can see we've got two commits in there. -one line. There you go. Make sense? Question?
Is there a way to see, like, you see, like, when they were made and, like, all that, but can you see what actual changes were made? Is there a way to look at the commits?
There might be a way to do that. I know you can do that like through GitHub's interface that it has for reviewing the history. But from the command line, I'm not sure what the command would be, and it's frankly easier to just jump back using checkout, take a look in manually using like your, regular commands, and then jump back to where you want it to be.
If you check out, would you have to commit to make that really normal, or?
You can branch off of old commits. So, like, if you have a chain of commits, right? What you can do is you can branch off, make some modifications, and then try to merge it back in with another, to another commit. So, merge to, and then make a version that has these changes. That's a thing you can do. but we haven't talked about branching yet. So let's talk about branches and the head state. So you may notice that what we produce here is a long series, a chain of commits, right? These commits actually can have a branching structure. It's possible to take the project, say, okay, I'm going to start a separate history for some other modifications that I'd like to make that I don't want to modify the original branch while I'm making them. You would do this, for example, if you were adding a feature and you wanted to, program it up, debug it, and make sure that it's working well before you snick it back into your sort of proper version of the project, right? This is frequently how workflow works with multiple people on a project who are organizing things using a Git repo, right? This is in fact considered the good hygiene way of doing it. So, however, all repositories maintain what's called a master branch. I believe on GitHub they call it the main branch. So the master branch is the main one from which all branches come off of, and eventually the goal is to have them all merge back into at the end. It is considered the height of good manners to always make sure that the master branch actually compiles and works and isn't broken. So having a broken master branch is, generally speaking, a bad sign, right? Furthermore, the most recent commit in the series of commits is known as head. So the head of the branch is just the most recent commit. Each branch will have a head. If you're not in the head branch, Git will warn you by saying you're in detached head state. So you're not in the head. Yes? Any questions about any of that? So, what's the point of all of this again? It's to organize several people working on a project. So, while Git repositories are good and useful, they are probably overkill for pretty much any personal purpose. To require a Git history for the files on your machine is probably overkill. Where Git really shines through is the fact that you can take these repositories and synchronize them with other people's repositories, right? So, we have 3 additional commands, right? Git clone creates a local instance of a remote repository. Git push transmits commits to other networked repositories, including the one you cloned from. And pull receives commits from other networked repositories and checks out the current head. Make sense? So, I sure hope they haven't reset my login credentials. We're in. Excellent. So, new project. Create a blank project. Name is example project 2. There we go. There we go. We'll make it private, sure, why not? Create project. Oops, gotta fix some of it. Groups, just me. Just personal. There we go. There we go. Can't push or pull repositories. Oh. Oh, fine, I'm gonna use GitHub then. It's the same process. Repository name, example. Description, no. Private. Create. They'll ask you if you want to put anything in it. You can just say, make me a new file. Name, temp, contents, no. Commit. So, once you've gotten to this phase, you just have to do the following, all right? GitLab also has a button like this. Code, clone, copy the URL address, all right? Then git, let me just pop up here, git clone, paste the URL address. It will probably ask you, it'll ask you for login credentials for the site that you're using, right? Which you should be able to provide, no problem, of course. I've already configured my local Git installation to automatically provide my credentials to GitHub since I use GitHub a lot. Cloning, there we go, right? There we have it. Go to example. Temp is in there. Get it. Temp. I'm just going to show you modification. No with it. Give me 2 seconds, guys. There we go. Save that up. Git add. Git commit. Message. No! Git push. Sending, sending, sending. Bing, bang, boom. Take a look in temp.